Okay, so for this next part, we're going to talk about what happens when the electrons are in the circuit. So we already mentioned about how electrons are leave from the battery or the energy source, they travel along the pathway, and then eventually they come back to the battery. So we're just going to look at that in a little bit more detail. So there's two locations on the battery, like we mentioned. We have the positive terminal and we have the negative terminal, right? Positive and negative terminal. So the negative terminal always has the excess of electrons. So essentially what this means is there is lots of electrons found at the negative terminal. Okay, this is actually where the electrons leave the battery. Okay, the positive end of the battery is always deficient or has a deficiency of electrons, which means there is not a lot of electrons at that terminal. So this is actually where the electrons enter back after it's traveled throughout the circuit. This will make more sense once we look at a couple of diagrams. So the flow of electrons will always flow out of the negative end. The electrons will move around the circuit to go into all of the other components. So the switch, the wires, the loads, however many you happen to have in place for that circuit. And then of course it flows back into the positive end of the battery. So keep in mind, we only discuss electron flow when the circuit is running. So if you remember, we talked about the symbols, right? So the symbol of a closed circuit will look something like this, and an open circuit will look like this, where you have a gap in between. So here we have our battery. So this is a 4-cell battery. And we have a light bulb. So the electrons are leaving the negative terminal, moving throughout, and coming back into the positive terminal. So as they travel along, they go through the switch, through the light bulb, and then back into the battery. So keep in mind, this is considered to be a closed circuit. So meaning everything is properly running. So in this case, right, this light bulb would actually be turned on. Whereas an open circuit, so if you notice we have an opening here, so this symbol here is representing a motor. Okay, so you may or may not have seen this before. So the symbol for a light bulb or a lamp, remember, is that swirly with that swirl, that loop with the circle around it. The M with the circle represents a motor. So this is another type of load, right? So here we have our negative terminal and our positive terminal. You can see here that this picture is showing a 1-cell battery, but we have here an open switch. So this is considered to be an open circuit. So that means that this motor would be turned off right now. Right? The electrons are not flowing to reach this motor so that the motor can convert the electrical energy. So just keep in mind when you're drawing circuits, which we'll start to do this week and then in the following weeks to come, when you're drawing circuits, remember that if you have a closed circuit, you should show the electron direction. And if you have an open circuit, you should show that you shouldn't show electron moving because the electrons are off, right? Or they're not flowing. So how does it move from one object to another? So we know electrons will leave the battery at the negative terminal. So you have to remember one thing. Electrons have a negative charge. So what happens when you have a buildup of negative charges? Negative and negative will repel. So remember that same charges repel each other. So what happens is the electrons start to repel one another. So they essentially push each other along by repelling. Now, what ends up happening here at the load is just like the battery has a positive and negative terminal, loads also have a positive and negative terminal. So actually the electrons are being pulled into the load through the positive terminal. So remember that opposites attract. So the negatives are repelling here, but they are being attracted into this positive terminal. And then the same thing happens here by being repelled out of the light bulb. from the negative terminal and being attracted into the battery at the positive terminal. So it's basically a series of repelling, attracting, repelling, attracting. And of course, every load that you have in there or every component will basically either be repelling the electrons to come out or attracting those electrons to come in. So when we're talking about movement in a circuit, the negative terminal will repel electrons and push them through the wire, and the positive terminals will always attract electrons to come in. So the same thing happens with the bulb. The negative terminal will push the electrons out of the bulb. The positive terminal in the battery will accept them and attract them into the battery. So when we're looking at the flow of electrons, so let's say we have here, let's say we have a motor, and then we have a switch, negative, positive, right? So what's happening here is technically the electrons are leaving and then they are attracted in, right? So even though we don't really draw positive and negative terminals on loads, you always draw them on the battery, but you have to remember that they're kind of there, right? So the negative will be attracted in, then they're repelled out, attracted in, repelled out, attracted in. So depending on how many loads you have, of course, it depends on how many positive and negative terminals you have. So it's repelling, attracting, repelling, attracting, repelling, and then attracting once again.